Quadratic equations of class 10, chapter 10. In this chapter, we will be dealing with the definition of the quadratic equation and the identification of the quadratic equation, and we will be solving several problems on the quadratic equation. Firstly, let me deal with the definition of the quadratic equation. A quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0, where a, b, c are real numbers and a does not equals to 0. You should understand here, if you want you can change here x to the y. So what happens here? And let me write it later. Then here instead of a you can write any other real number b, c. Yes, right, these are real numbers. It can be anything like that. Yes, right, you can also state it like this: a y square plus by plus c. This is also a quadratic equation. Yes, right, you are all familiar with the real numbers, any real numbers. Yes, right. So let me deal with few examples of the quadratic equations. 2x square plus x minus 300 is equal to 0. Yes, right. Likewise, 2x square minus 3x plus 1 is equal to 0. And 4x minus 3x square plus 2 is equal to 0. Yeah, 4y square minus 3y plus 6 is equal to 0. Yes, right. Likewise, we can state many examples for the quadratic equations. While stating this example, 4x minus 3x square plus 2 is equal to 0, it is not written in the standard form. But even though it is a quadratic equation, by how to write this means minus 3x square. Firstly, I am writing the x square plus 4x plus 2 is equal to 0. By multiplying this into with minus 1, we will be getting 3x square minus 4x minus 2 is equal to 0. Yes, right. This is in the standard form. These two are okay. Yes, right. You can write it like this. If you multiply with minus 1, there will be no change. You can write like this too. Yes, right. This is a standard form of the quadratic equation. This is the standard form I have written in this way. Yes, right. Any equation of the form p of x is equal to 0, where p of x is a polynomial of degree 2 is a quadratic equation. Here we should understand that polynomial of degree 2 is right. One should not forget, polynomial of degree 2 is a quadratic equation. Is right, and the equation should be of the form p of x is equal to 0. When we write the terms of p of x in descending order of their degrees, then we get the standard form of the equation, that is ax square plus bx plus c is equal to 0. A does not equals to 0 is called the standard form of a quadratic equation. Yes, right. We here you can see 2x to the power of 2. Yes, right. X square, after that x, whereas here it is not there, means x to the power of 0 is there. Yes, right. You should understand that 300 into x to the power of 0, as you are all familiar that x to the power of 0 is equal to 1. Yes, right. You should not forget this one. So here you can rewrite it as it here as like this: ax square plus bx plus c x to the power of 0, whereas here 1 is right is equal to 0. This is the standard form. Here 0 is there, here 1 is there, here 2. In the decreasing order is there, is right, x to the power of 2, x to the power of 1, x to the power of 0. It is in the decreasing order of their decrease. This one is the degree, yes, right. So this is called as the standard form. I have written all the four equations here in the standard form. Here one should understand that in the definition itself it is stressed that a should not be equal to 0. Why? Once if a becomes equal to 0, x to the power of 2 also will be multiplied with the 0. So what happens here, this number vanishes, that means it will be equal to 0. So as it becomes 0, the degree of these equations will be x to the power of 1, yes, right. So it's the degree will be 1. As the degree will be 1, it will no longer be a quadratic equation. That's why it is stressed here the a cannot be equal to 0. Here also in every statement we will say that a should not be equal to 0. If this a becomes equal to 0, this uh, polynomial will not be a polynomial of degree 2. That's right, this vanishes. That means this will be equal to, as a becomes 0, this whole term will be equal to 0. So we will stress that a does not equals to, a should not be equal to 0. Check whether the following are quadratic equations. First problem here is x plus 1 whole square is equal to 2 into x minus 3. So here I will expand using the identity a plus b whole square is equal to a square plus 2ab plus b square. So here a is equal to x and b is equal to 1. So what happens here? X square plus 2, a means here x. What about b? B is 1, so 1 plus 1 square. So here right hand side I will multiply with the 2 into x, 2x, and plus into minus is minus, 2 3 is 6, yes, right. So x square plus 2 into 2 ones are 2 into x, 2x, plus 1 square is 1 is equal to 2x minus 6. I will take the RHS 2x minus 6 to the LHS. So what happens here? X square plus 2x plus 1 minus 2x. Here minus 6 is there. When it moves to the left hand side, it becomes plus 6. This will be equal to 0. Here plus 2x minus 2x cancels. So x square plus 1 plus 6 means 1 plus 7 is equal to 6 plus 1 is 7 is equal to 0. Here x square plus 7 is equal to 0 is a quadratic equation, as this equation is having a degree 2. This is a polynomial of degree 2. This can be written as 1 square 1x square plus 0x plus 7 is equal to 0. So here ax square plus bx plus c is equal to 0. That's right. This is the standard form. Therefore, this is a quadratic equation. It is a quadratic equation. Next problem. Second problem, x square minus 2x is equal to minus 2 into 3 minus x. So x square minus 2x I am writing as it is, and now I will multiply minus 2 with 3 minus x. Minus into plus is minus, 2 3s are 6, minus into minus is plus, 2 into x is 2x. Let me now shift minus 6 plus 2x, what is there in the right hand side to the left hand side. What happens here? X square minus 2x. Yes, right? I have written as it is. Minus 6 when moves to the left hand side, it becomes plus 6. And plus 2x when moves to the left hand side, it becomes minus 2x is equal to 0. So what happens here? X square minus 2x is plus, sorry, minus 4x plus 6 is equal to 0. Yes, right? So which is of the form ax square plus bx plus c is equal to 0. It is in the standard form. It is of the quadratic equation. So therefore it is a quadratic equation. Let me move on to the third problem. The third problem is x minus 2 into x plus 1 is equal to x minus 1 into x plus 3. Here now let me make a simple multiplication. X into x plus 1 minus 2 into x plus 1 is equal to x into x plus 3 minus 1 into x plus 3. So what happens here? X into x is x square plus x into 1 is x minus 2x minus into plus is minus 2 ones are 2 is equal to x into x is x square plus into plus is plus x into 3 is 3x minus 1 into x is minus x minus into plus is minus 1 3 is a 3. Yes, when we shift all the RHS terms to the left hand side, x square plus x minus 2x minus 2, now I am shifting minus x square minus 3x plus x plus 3 is equal to 0. You see here x square is there, this one is plus x square, whereas here minus x square. Plus x square minus x square cancels. So what I think is, there is no need of further solving this problem. If you solve this further also, what you will be getting here is, you can't get a term with second of degree 2. X minus 2x is minus x minus 2. Minus 3x plus x is minus 2x plus 3 is equal to 0. So what happens here? Minus 2x minus x is minus 3x minus 2 plus 3x is plus 1 is equal to 0. It is not a quadratic equation. Therefore, it is not a quadratic equation, as there is a absence of x square. X square is not there. You see this equation, ax square it was there, x square it was there, here also x square was present, here x square is absent. That's why it is not a quadratic equation.